Ranok everybody. We with our fluffy assistant talk about Ansys, and it's a course about Ansys Workbench CAD capabilities. And the next question from the list, it's a work with General CAD, with geometry from General CAD like SolidWorks, Creo, NX, Siemens SolidWorks, Catia, Inventor, Fusion, and many others. AutoCAD, for example. So, it's an object where we can work with geometry during Ansys Workbench, and this is more general. And more general way, it's to import geometry file from your CAD system. You can import in native format, in some native format. You can import on a natural format, so it can help you to work with geometry, but there are some questions about interoperability, about importing and exporting, so we need to talk about that. Okay, this is our Ansys Workbench. This is our, this is our workbench. And this is our folder with geometry. It's a natural format. It have extension which called set. It's a standard Ansys text file. So it's a geometry which described with natural formats which are more closed born for Ansys kernel. It's Ansys kernel used by SpaceClaim, AutoCAD, Autodesk, Inventor, and Autodesk Fusion, and many other software. It's not very correct to say that Inventor and Fusion used Ansys because they used Autodesk Shape Manager, but Shape Manager it's a fork of Ansys standard, so we can say that. And there are a couple files that have small difference, but the small difference affects our design process and our workflow. During today's video, we will use only first and second file. So we add our file into our project by simple drag and drop, and it import them. Now we need to add static structural. Double click on a model and we open. During it open, I can say that this is, and this is, it's a icon which explains that we work with geometry from set file, so from Ansys. Okay. We have something like that. It's a simple object, it's very simple object, and we have some problems with it. First of all objects made from steel, because it's material by default, and in most cases this object made not from steel but from wood. If this chair have look like this, but there are some additional problem with this geometry. And please stop this video, look here, and you will see the problem, and you can say what problem do we have here. 3, 2, 1. I hope you write a comment and I explain. Take a look here, and we change our unit system to be more clear. And as you see, this object wide, and it's almost 10 meters. 10 meters wide. So it's very big chair, very big, and those problems can appear even with original file format and very general for some natural CAD formats. It can you can find this problem in Ansys, you can find this problem in FEMAP, you can find this problem even in CAD systems when you import in some geometry, and it can be in couple reasons. First of all, file doesn't have description about which unit system was used when a geometry was saved. For example, you create geometry in millimeters, save it. It doesn't write any unit system, and then when you import in another CAD system, it imports with default settings, and those default settings can be an inch or, for example, C, so it can be meters. There are a lot of different ways which can affect those scale of your geometry. That's why a lot of Catia software have this object which show you dimension of your simulation object, and it's very important to select some object and see what size does it have. So first problem, it's a material. Second problem, it's a scale. And let's do some loads and so on. We add here an force, and it can be by components, minus 1000 of newtons, so it's 100 of kilograms. And also we fixed all our legs. With Ctrl key we select them, we fix them. It's not fully correct fixation for this type of calculation, but it's not very important for our current tasks. So solve. It's very small task, so it's solved very quickly. We add deformation, we add stress, we read result, and we can see something like that. We change dimension to millimeters, and we see that our stress are very, very small. And it's no matter that this object created from steel, even if it would be created from wood, it also has very small stress, and this stress in reason that we have not right scale factor of our model. But we also have problem like this one. This one leg doesn't help this plate to stay and to work. So why it is? Its reason very simple. It's a list of connections, and it's a list of all automatic contacts, and a lot of different Catia software for now creates automatic connection which must help you in creating your simulation design. And in most cases, even in Ansys, when you create in automatic way those connection, you use percentage of size of your model, of gabarites, and for now it's almost 50 millimeters. And if we try to work with this object, we will select it. Just a moment. Okay, this surface and this surface, and as you see, that dimension it's 250, so it's 5 times more than contact tolerance, so it doesn't create a contact here. Okay, let's create the contact here by our hand. We create bonded contact. We recalculate and nothing happened. Nothing is changed. Reason of this because we use fully automatic creation and pinball region and trim contact are also automatic, and these numbers depends with this number. So in automatic way it's not very good way to solve your tasks fully automatic. In reason that it will create contact in some place where you don't need a contact. It doesn't create a contact in place where you need a contact. And if you have a contact, it's not always real type of contact that you need with real preferences. So please be careful, please check your model, please check your size, check your material information, check your contacts very carefully, and check your results. Okay, this is good. We create that, it's not a problem. And let's take a look into one question, and we return to this question later. First, we select this surface, this face. Okay, let's select this face. Let's came to Home tab and choose Select Information. Select information are present here when we turn it on. So let's take a look here, and we see those digits. This is an area, this is a place of centroid and so on, but we don't need this, we need those digits, remember. And let's do some changes. Choose replace geometry with second our object. In this object we change our unit size, we do some changes with legs, so we try to do our best to improve our model and to clear all mistakes. Update geometry from source. And yep, it's almost half of meters. It's 400 of millimeter length, so it's much better. It's our chair, okay. And we see that we doesn't have any problem. We can solve, but we have a problem. This is how it tried to work. and it's not good because we fix those part of legs, we fix those faces, they can't move. We put force here. Why it don't deform here? Why it deform here? Okay, let's take a look. Force, where our force? Why it is here? Fixed support. What the hell? We support here, we support here, we support here, and this is 3 phase. And where we have the 4th phase? We doesn't see 4th phase. So we have 3 selected phase, and this phase we don't fix. Why it's so? Okay, let's take a look here. This brown object, and this is face. Okay, let's select this face and take a look to selection information. And if we remember digits what we have, it was 9 and 123. If we select other, we see other part ID and other reference ID of face, and this force and this fixed support was applied not for these faces, because Ansys and any CAD software doesn't know that we need these faces. It applied to some parts, some faces with those numbers. And if we change our geometry and Ansys can find those objects, it will apply supports, fixation, contact, any type of features to those numbers. If we apply something to body, it tries to look with these numbers and apply to that. And if this body change this number, his number, if this face change his number, it apply not to this face, not to this object, but to another. And when you edit in your geometry in your original CAD system and re-import it here, it very often change some numbers. It changes these numbers even when you inside of your native CAD, but it's more simple to work inside of your native CAD, so it's not so big problem. But sometimes you see that you do some changes and you have a problem in history, in connections, and so on. It's a reason that your CAD system store all information also with those numbers. So when you change something, it came here, and you can change dramatically your analysis, and you must check this one. Very good if you obtain not this mark, but this mark. It means that Ansys lost all data. It means that you doesn't have faces objects and so on with those numbers. Why it's better? Because you will see this problem, you will check them, you will change them, and you will obtain good result. But if you see something like this, you think that it's okay, it's no problem. For now, it's very simple to see that we have not right solution. But if we work with parameter design, if we work with optimization, we sometimes can change geometry, obtain very different result, and do very different analysis. Sometimes you will not see those differences because it will be very small. And you must check this one. Okay. If we don't change anything, do we obtain changing of this result? Let's try. First of all, I came here to material and say that I want to add plastic, and I want to change for all our part material from structural steel to plastic, ABS. Okay. And now we open our workbench, double click on geometry, and it starts Ansys Discovery. And imagine that you do some changes here, and then you re-import geometry. I will not change anything for simple way. I want to show result of how open your imported geometry with Discovery will affect your work and your analysis. It doesn't seem that Discovery is a bad CAD system. No. But you need to understand that. So we open geometry. We see this geometry. We update geometry from source. Take a look to these colors. And it change colors. And we have a problem with contact, which we create by our hand. We have problem with forces and fixation. And why do we have those problems? In reason that all parts and all faces have very different numbers. All bodies, all faces change this number. Okay. Additional problem. We have structural steel, which we changed to plastic ABS, and now we have structural steel. Structural steel S275. Not ABS, not structural steel, but this one. This material came from CAD, from Discovery. This is. And if we change this material, for example, to ABS, do some changes, for example, I don't know, hide others, and add 1 millimeters, for example. Okay. show all. And update geometry from source. This object doesn't change number, doesn't change, it doesn't change color, but all objects, even those objects that we don't change in our CAD system, change our ABS to structural steel. In reason that it take material from CAD system. And sometimes it even will affect your solution, because Ansys will say that it can solve, because your CAD material doesn't have some important mechanical properties for calculation. It can be so. So when you importing your geometry, when you re-importing your geometry, when you change this geometry in native CAD, in other CAD, please be careful. Please be careful to check all data that you import. Because it's not a problem of Ansys. It's a problem of operator, of engineer who work with this one. And you need to know that this problem is present. How to solve this problem in some way, we talk on the next video. I hope this video will be helpful for you. And if you have those problems, please write a comment. Especially if you have this problem and you don't understand why you have this problem. And now you understand. Thank you, and see you later.